Hello and welcome everyone. Thank you for joining us today for our webinar titled Make Your Own AI with Recipes in H2O Driverless AI. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Michelle Tanco is a customer solutions engineer and data scientist at H2O.ai. And now before I hand it over to Michelle, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Without further ado, I'd like to hand it over to Michelle.
Great, thanks Patrick. Hi everyone, thanks for your time today and joining us in this webinar. Today we'll be talking about H2O's automated machine learning platform called Driverless AI and how to customize this with recipes. H2O AI, the company, just to give a quick overview in case anyone's not familiar, we have over 220 data science experts and we're used across the world, both our enterprise products and open source products with many different companies, universities, and we have a member meetup of about 200,000 people. We're based in Silicon Valley since 2012 and we have a global worldwide presence with offices in Prague, Chennai, Paris, and so forth. Today, we're going to be going over three main questions. What is automated machine learning at H2O? This is sort of a big question. It's very popular in the marketplace right now. So we'll be talking about H2O's enterprise solutions automated machine learning, driverless AI, and how that works. Next, you're going to talk about how to customize the different pieces of driverless AI, what's available today, and what's coming soon in later releases. And then we'll go into how to get started with making your own AI, both using the recipes we're going to be talking about and how you can learn how to write your own. All right, so let's jump into Driverless AI, an end-to-end automated machine learning platform. A typical data science workflow is as follows. We often, after choosing a business use case, collect different data sets that will relate to that business use case and prepare them using ETL, joining data together, checking that it's clean, exploring the data set. The next step is actually doing more analysis there, understanding different correlations between columns, understanding if your data is as clean as you want, and creating new features that might be more predictive to your use case. This is an iterative process. The next step is actually building the models here, also an iterative process. So what's the right type of algorithm for this use case? Are the engineered features I created actually working in this algorithm, or do I need to go back a step and create new features? As we're creating these different models, there's other steps we need to do, like tuning the models or hyperparameter tuning. Once we've created a model that seems to be performing well, has good metrics, we want to understand it to make sure it actually makes sense in our business. This is understanding the key features, which features are important, how the model is making decisions, and if we can explain it to ourselves, to our business, and to regulators. Finally, once we have a good model, it seems to be matching what we expect from our business knowledge, we're ready to put it in production. That is the deployment step. And so this is going to be where our model actually has business value. It's scored on new data, it's making predictions that are actionable. And without this last deploy step, this has mostly just been a science experiment. And so this is a step which really can give us our business value. Driverless AI, H2O's enterprise automated machine learning platform, is focused on mainly the last four steps of this process. So once we have an idea of our business use case and the data sets that we need to solve it, we're going to be doing some automated feature engineering, exploratory analysis, model building, machine learning interpretability, and building you a production-ready deployment strategy. And this is what we'll be focused on today in this presentation. So let's actually talk through how Driverless AI works. The first step is to pull in a data set. And so this is a data set which usually has been mostly prepared ahead of time. We will have some prepared steps that we can do in Driverless that we'll be talking today with recipes. But for the most part, we want to have the data that we will be using in our production model somewhat ready. We have over 12 connectors to pull in data from any generic SQL warehouse, to specific cloud and other on-prem strategies where you might be keeping your data. The next thing we want to do is our exploratory data analysis, where we understand what is in our data set. And this is done with automatic visualization. AutoViz was built by Leland Wilkinson, who is the author of Grammar of Graphics, one of the first statistical textbooks about using visualizations in statistics. What AutoViz does for you is it creates common statistical charts on every column and combination of columns in your data set, and it returns back to you the interesting ones. So you don't have to take the time, either in a UI or writing code, of trying all the different combinations and trying to understand what might be messy or interesting in your data. This is done for you, and all interesting visualizations are shown, and then you can explore them as you need. The next step is our automated machine learning process, which is done with a genetic algorithm. In this process, we're actually doing a very long competition of many different models competing against each other. So in each round of this competition, some models will be created. They're going to have different features, either from your original data set or new features that we've created. They might have different algorithms, so XGBoost versus GLM versus follow the regularized leader. And they're going to have different hyperparameters. In this competition, the best models are going to move forward into the next round, and the ones that don't perform as well for your business use case are going to be modified and then go to the next round and try again. And in this way, we have a meta learner on top, which is learning what works on your data and what doesn't, to create for you the single best model or ensemble of models to go into production. I want to talk a little bit about the automatic feature engineering here. So the types of things that we're doing, where we're taking your data and creating new features, some of these are going to be really straightforward, like extracting the date out from extracting the month out from a date to create an understanding of seasonality. But others, these are going to be a bit more complicated, like clustering together several different columns and understanding the interactions of those columns. Often in an experiment, we see that several thousand features have been created in a 1-hour experiment. And if you think about the amount of time it would take you to think of and code all those different feature engineering, that's just one of the ways that driverless AI can save data scientists a ton of time. Once we have our final best model or ensemble of models, we want to understand them. And this is done in two main ways. The first is through automatic model documentation, which is a data science insight into step 3 and what happens. So we don't want this process of models competing against each other to find the best one to be a black box. We really want to make sure that the data science expert is understanding what happens and that it makes sense for their business. So this auto documentation is going to talk about the data that you trained on. What was the distributions of that data set? Were there any interesting findings we found, like maybe the training and test data set were very different from each other, so that tells you that your data is changing over time. Was there, what were the new features that we found? How did we find them? How were they created? What are the final new features in your model? What different algorithms were tested? Which ones worked? Which ones didn't? All in all, this can be a 20 to 40-page report, and it's very on the data science technical side, but to make sure that we really understand what's in this experiment. And this can save time as well, as often data scientists are expected to document their workflow or what their model, how their model works and how it was built. So this comes out of the box for every experiment. The next way that we're looking at understanding the experiments is with machine learning interpretability. And this will actually tell you how the model makes decisions. So we do this through some of the state-of-the-art functionality like Shapley values or Lime reason codes, which tell you which features are most important or contributing the most to your model's predictions. This can be really helpful globally because we can say, well, in general, this model thinks that this feature is important. But it also can be helpful because we can get these reason codes for each individual row. So we can say, our model thinks that Joe is going to churn because he paid $45 for his cell phone bill last month, and that's too much for him. He's going to leave us now. So you can get individual reasons of why the model thinks someone will do a decision, which can help you with either keeping them from doing the bad decision or just understanding your data a little bit better. Finally, when we're ready to go in production, this is where we have our automatic scoring pipelines. So everything that we've done in step 3 and 4 are available in our scoring pipelines. We have the ability to take new data, do the automatic feature engineering, get the model predictions, and in some cases get the reason codes, and get all of these in your production environment. These are going to be pipelines that are prepackaged in either Java, C++, Python, and callable from R, so they fit into your deployment and production environment. Many of our customers are running these as a REST server, running them in a Docker container in the cloud, embedding it into their existing Java APIs. Wherever production is for you, the scoring environments can sit nicely and work in your existing environment. So you're not required to use Driverless AI or our product anymore for production. You can have the scoring pipelines run exactly where you need them to, and this saves a lot of time as well. So this is our overview of Driverless. We haven't talked about recipes or extensibility at all. This is what you get out of the box, and it is often good enough for solving problems. But we have many advanced data scientists or domain experts that might want to customize this process to solve their more pressing or complicated use cases. And that's where we can get into recipes. So as a quick overview, just to see it on the list, these are the main features that we've talked about. Driverless AI has auto visualization. It's creating us scoring pipelines which include feature engineering. We're able to understand the model with machine learning interpretability. And we can handle many different types of use cases, anything that's supervised where historically we can learn from the past on what happened, including NLP, forecasting, classification, and regression. And we're able to deploy really flexibly. The rest of the presentation, we're going to be talking about how to customize this whole workflow. And that's going to be through something called Bring Your Own Recipes. So now let's get into the customization. Before we talk about the main ways of customizing Driverless, which is through recipes, we should first define recipe. So when we talk about a recipe at H2O, what we're thinking about is a piece of your final scoring pipeline. So if you think about everything it takes to build a good machine learning pipeline, it's not just an algorithm that runs and creates you a model. We have to prepare the data somehow. We're going to do some feature engineering. An actual algorithm is run and it has some hyperparameters. And if we're going to be running different models and competing them against each other, we need a way to pick which one is better. So each of these components, we're considering a piece or a recipe of the scoring pipeline. And the main ones we'll be talking about are those 4: preparing data, feature engineering, algorithms, and scoring metrics. So out of the box with Driverless AI, we have 12 ways to load in or sort of bring in data from wherever you have it. We have 34 feature engineering transformations, different ways of manipulating your data to make it more predictive or find that predictive juice in it. We have over 9 algorithms with many more coming, about 3 in the next release, I believe, for building predictive models. And we have 19 different statistical metrics for optimizing your model. So this is what's happening out of the box in this experiment when we're testing different things against each other. But with recipes, all of these numbers basically become unlimited. So we have over 140 pre-built recipes, and we'll talk about some of them today. But also you can create your own for whatever you need for your business use case. So why should you add your own recipes in Driverless AI? Shouldn't Driverless AI be good enough on its own? Well, often it is, but having new open source recipes, that 140 number I just mentioned, built by the data science community, gives you the ability to add in the latest and greatest algorithms before they've been officially vetted, tested, and incorporated into the product. So we are taking several of our best open source recipes and baking them into Driverless out of the box. But with open source Bring Your Own Recipes, you can get them faster and test them out quicker. This also allows data scientists to focus on domain-specific functions. So some of the recipes we'll see will be very general, like maybe you want to add in a new algorithm, Cat Boost, which doesn't come with Driverless AI, but it seems to do very, very well, especially in like casual competitions. But other recipes are going to be a lot more domain specific. For example, you might have an algorithm where you want XGBoost, but you want it to have a specific loss function that matches what you need for your business. So in that case, it would be a little more custom and specific just to your needs. It also allows you to have full flexibility and customization of driverless. We have a lot of what we think are some of the best recipes, but you can fully customize it with what you actually need at your business, which can be quite helpful. And then the final point, what we're starting to see a lot of our customers do is having their own private recipe cookbook that they collaborate for data science. This allows their expert data scientists to create the recipes that they need, and then their maybe less experienced or newer data scientists can add these into the driverless AI and don't have to write any code or have to really understand how they work. They can have the specific domain recipes that they need. So this is a way for team collaboration as well. All right. So now that we've gone through recipes, we're going to talk about what all is customizable in driverless AI. Most of these are going to be recipes or those Python snippets that we're going to add into driverless. But some of them that are coming soon are worth mentioning because they're pretty cool and exciting, but they're not necessarily recipes. So what we're going to talk about today is loading data recipes. So basically custom connectors, custom ways to bring data into driverless AI. We also now have the ability to modify data recipes. So once you have a data set in driverless AI, how do we change that? A new feature that's coming that's been highly requested, so I wanted to mention it today, is custom visualizations. So this is in AutoViz where we're automatically creating these visualizations for you. You'll be able to create your own now. So it's not a recipe per se, but we'll go through it as anyway because it is a pretty cool customization. The fourth one is going to be data pipeline recipes. So this is going to be similar to number 2, but it actually will be available in your end-to-end scoring pipeline that you can put into production. We'll then talk about 2 types of feature engineering recipes, which have been available since the release of recipes in 1.7 last July, and then algorithms and scores as well, which have been available since 1.7. The last 2 customization things that we can mention is the ability to customize the auto report. So this is a feature that we've had for the last year, but not a lot of people know about, so we wanted to mention today. You can basically have the final auto report have exactly what you need in it. There are many out-of-the-box functions that you can change for this report. And then something that's coming soon and will get its whole own webinar is the ability to do bring your own machine learning interpretability. All right, so now we're going to jump into these different types. One thing just to mention really quick, these recipes, and I don't believe we said this earlier, but these recipes are all Python code. So if you know Python, you can write a recipe. If you don't know Python, that's okay, you can use a recipe. So all recipes are available to be consumed by someone, and then to write your own, they're all done in Python code with a standard template that we have in a repository I'll show you at the end of this. So the first type of recipe we'll talk about is loading in data. So out of the box, driverless AI has 12 connectors to bring in data. This is a JDBC connector for any SQL warehouse, and then special connectors to other locations like S3 or Azure Blob Store. What we're doing with Bring Your Own Recipes is that you can use any Python code to load in a data set. One thing that's important to note, just like every other data connector, this Python code is not going to be part of your final pipeline. So even though you can write anything in Python, if you're going to do any sort of special data prep or clean your data, you need to remember that this won't be done in production. So these slides will be available at the end of the presentation, and all of these links are going to go to the public GitHub repository where this code actually lives. So you could use this recipe yourself, and we will talk about how to use recipes later in this presentation. So just something to keep in mind. We have over 140 of these recipes available. I'm going to tell you about 20 interesting ones today, and then all these links go directly to them. So 3 types of loading data recipes to give you an idea of what's possible. One, there's a list of about 20 file types that are supported by Driverless AI, anything from Excel files, CSVs, and so forth. But if there's an unsupported file type where you want to load in that data but Driverless can't, but you can read it with Python, this is now available with recipes. So this is an example of reading in SAS7 BDAP files. So you can bring in those SAS files without having to translate it yourself. You can just use this custom recipe and it will load those into Driverless. We also have examples of loading from external data stores that aren't supported out of the box. An example here goes to MongoDB. And then you can also pull data from any public URL. So if there is a public data set you want to use, but you don't want to go to it, download it to your local machine and upload it, you can now use a Python recipe that will pull it from the public URL directly into Driverless. And this can do additional steps such as joining the data and pre-processing, but again, that won't be in the final pipeline. So these are some examples of bringing data into Driverless AI with a data loading recipe. Next, we're going to talk about how to modify data. So one of the questions that we were frequently getting when we were talking to folks about Driverless AI is, okay, well, what if I load a data set and I'm exploring it with AutoViz and I see that there are some outliers I want to remove, or I see that one of my columns is actually, you know, it's off by a factor of 10 and I just want to change that column. How do I do this really quickly in Driverless? The story used to be you had to leave Driverless, prep the data, and bring it back in. But now we have the ability with modifying data recipes to actually use Python to fix the data within Driverless. So any code or any data that's been loaded into Driverless, we can now change using Python code. Again, this is just sort of like our loading recipes. This Python code won't be in your final pipeline, so probably not a good choice for creating new features that you might want in production. But this can be really nice for anything that's related to your machine learning modeling. Maybe you want to test making a regression problem classification instead, or maybe you're doing some early pre-processing on a model. It's not going to go to production anytime soon, but you're trying to see what might work or what might not. Those are the times when it would be really good to use a modifying data recipe. So here are some of the examples that might be interesting to you. One of them is if you have any rows that have a missing target value, they won't be modeled in Driverless AI because we don't know what the true value is. So something that can happen with forecasting, you would want to know what the value was for every date so that we can look historically at what happened. And missing dates can make our model less accurate. So we can have a modified data recipe which could look for any missing dates, add those rows in, and fill them with the mean, for example, or whatever made sense for your business. Maybe 0 is the right choice if it's sales. This can run on your data and would be a good choice for improving our model, and it wouldn't be something we would need in production. Another idea would be to do unsupervised clustering to break up a large data set into smaller subsections. So maybe you would want to make a separate model for each cluster because you want to understand how different types of customers are behaving, or there's a type of customer that's not modeling as well because it's too different from everyone else. So this is an example of how we could run k-means to create several different data sets and then run an experiment on each of those. We might also want to try different types of modeling techniques for our data. So a use case with a customer recently, we had transactional data. So it wasn't good for time series forecasting because it was very common transactional data happening a lot of the time. But what we wanted to do was to aggregate and group it so that it would be IID, where basically every row is independent from each other. And so this is a data recipe that would do that on your data. It takes transactional data and it aggregates it up to IID. All right, so the big caveat for the last two recipes were it's not in your final pipeline, which depending on what you want to do with your pre-processing might be important to you. Maybe you want to do pre-processing that can run in production. And that is available coming soon at a release later this summer with data pipelines. So data pipelines will be available in the Python scoring pipeline. And depending on how complicated your data pipeline is, it could also be available in the Mojos. What the pipelines are custom data prep via Python, again, and it will be part of your Python scoring pipeline. So the only rules for these data pipelines is they can't change the name of important columns. So they can't change the name of your target column. If you're using a weight, fold, or time series column, those names can't change either. And that's because these run in the scoring pipeline, and you've already selected those names when you're setting up your experiment in Driverless AI. Anything else can happen. So this is where you have a lot of power as the end user or as the data scientist writing these. So we do want to think and make sure that we're not writing code that wouldn't make sense on production data. So you wouldn't want to maybe use the target column in this Python recipe because you're not going to know the target in production. But you do have the ability to write anything that you want to here. So there aren't public examples of these yet, but to give you the idea of what you might want to do is you could have special rules for replacing missing values that come in at production time. Driverless AI does handle missing values automatically. This is not something you would need to do, but again, the idea here is customization of what makes the most sense for your business. So maybe for your business in a certain column, missing, you know that missing means that there were no sales or something like that. You could have a rule that forces all missing values to be replaced by a special number. Another idea would be custom text cleaning for your use case. So if you knew you had a lot of HTML or hyperlinks that you didn't want to be used in the NLP feature engineering, then you could use that in a pipeline recipe to clean that text ahead of time. And then whatever special data prep you have for your use case. So when we think about the end-to-end driverless AI platform, where this runs, you would load a data set, and then when you set up your experiment, it's going to run a pipeline first, and then it will do the automatic feature engineering for you. So the data pipeline will always be ran on your data. Which gets us into feature engineering. So feature engineering, for anyone that's not super familiar with driverless AI, what's happening with the feature engineering is we're taking your original columns and we're looking at them in different ways. Like I mentioned, this could be extracting the month from a date, doing clustering, running TF-IDF on text columns, but we're basically creating new columns in your data set. Now, not all of these are going to be used, and that's how feature engineering is going to be different than a data pipeline. The data pipeline will run once on all your data. Feature engineering is going to create hundreds or thousands of new features on your data, and the driverless AI genetic algorithm will pick out which ones are predictive and working well and which ones are not. And so if you include in a feature engineering step, it may or may not end up in the final pipeline. So if it's not predictive, it's not going to be used. And that's what's very interesting about the feature engineering is it allows us to try a lot of things on our data and see what works and what doesn't. The part that's coming soon here, currently there is a single pre-processing step. It doesn't happen all at once. It happens over time in the experiment. But if you take your original column and you run TF-IDF on it, those new features are not going to be changed again. That's as far as they're going to go. So there is a new concept coming in feature engineering for the release later this summer called pre-processing feature engineering. So basically there will be iterations of feature engineering. You can say, I want you to do these kinds of feature engineering first, and then once you've found the predictive things there, I want you to try these other ones. So this could be nice if you wanted to think about putting feature engineering into other feature engineering, which is a request we've been getting. So some examples of these is to incorporate new types of data. Out of the box in driverless today, we don't have any geolocation feature engineering. So here's an example of calculating the distance between 2 points. So what this automatic feature engineering will do is it will find any point or any columns in your data set that are numeric and look like latitude and longitude, and it will return the distance between them. Now this is one that you might want to use in another feature. Maybe you want to take that value and cluster it with other columns. But this will start to give you an idea of how location can impact your predictive model. We can also use these to extend to new use cases. For example, we have a recipe that will compute a recommendation matrix for you. So if you think about use cases where some users have watched some movies and we know what they like, but we don't know how they feel about others, that can be a very big matrix that needs to be created. So the recommendation feature engineering can do that. And another idea of sort of the pre-processing feature engineering we might want to do would be extracting a list of key business words. So maybe making new columns that have flags if your domain's most important words were used in text. And then those flags could be used in another feature engineering step. That's how our feature engineering section works. All right, so while we're creating those new features from your original data set, we're also going to do the actual model building step, or an algorithm. So algorithm recipes are how we actually model the data to make predictions. Driverless AI is going to use the most predictive model, or models, plural, for the final scoring pipeline. And there is a step that will do automatic ensembling for you. So if there are two models that are very predictive, but on different parts of your data set, we'll use both of them together. Right. Okay, and then one note, we had a few, in the previous releases, we've had several bring your own algorithms that were very successful for a lot of our customers, and we saw being used time and time again. So those are currently being incorporated into the product and will be available in 1.9.0, which is the release I've been mentioning that will come out later this summer. So those official, soon-to-be official algorithms are going to be BERT for NLP, and not just BERT, but several flavors of BERT. And then also we have a special algorithm for imbalanced regression problems. Basically, think about when you have 0 most of the time, and then occasionally there is an event that happens and it's really, really high. So those imbalanced regression problems, we had a special recipe for them. So that's an algorithm that you can use and bring your own recipe today, but it will be available out of the box later this summer. All right, so some of the examples of algorithms you might be interested in is looking at forcing a tree-based algorithm to split in a specific way. So the example here would be a custom loss function for XGBoost. We also have new open source algorithms that are really focused on explainability. For example, XNN, or an explainable neural net. And then you can also include the latest from open source. So even if we haven't had time to officially bake a recipe into the product, like BERT, for example, or CatBoost, you're still able to use it from the open source. The last type of recipe that we're going to talk about is scoring metrics. So we've mentioned that driverless AI is a competition, and we're choosing the best models that meet your business needs. But how do we know if one model is better than another? And that's done with a scoring metric. Usually this is going to be a statistical measure. For binary classification, common ones are going to be things like F1 score or area under the curve. For regression, you might have the root mean squared error, or MAPE. But we now have the ability to add in any scoring metric you want. And one of the questions we're getting regularly is, are customers wanting to use maybe their own business KPIs? So they're statistically backed, but there is something more important related to the actual business problem they're trying to solve. So some examples here would be sort of a specialized statistical measure. So something you wanted to use that wasn't a standard, or maybe we didn't have in the product. For example, the log of the mean absolute error. So that's something you could add in yourself. Examples of a business KPI you might want to use, we have mean profit per outbound marketing letter. So basically this will tell us which model is going to get us the most profit for if we send out a letter to someone, because there's a cost for sending out a letter that is unsuccessful, and then there's a profit for sending out a letter that is successful. So now we're starting to add in more of our business metrics into our scoring metrics. And then a new feature that's coming soon, the release later this summer, this is going to be including columns from your training data. So if you have used custom recipes over the last year, you might know that the scoring metrics today only take in the predicted value and the actual value. But if there's something about your data that you want to use in that scoring metric, you can't do that today. So that's what's coming soon. An example of why you might want to do that is to calculate a standard statistical measure like log loss or AUC, but to include a specific column like an amount or a customer ranking or a customer importance level, so that you can basically weight the scoring metric. We do have the ability in Driverless out of the box to add in a weight column, but that is used in the models as well. So if you wanted to use additional features in the scoring metric but not the model, that would be this new feature that's coming. All right, so that was more the theory, what's coming, what we have today, how it all works, and some examples. But now we're going to go through what this looks like in Driverless and how you can actually start customizing Driverless AI to make your own AI today. So we're going to go through each of these, which we just talked through some examples of. The first is going to be loading data. So here we have a screenshot of the Driverless AI datasets page. When you click on Add a Dataset, all of the out-of-box connectors are available there. We have two new options, and these are going to be our data recipes. We can upload a dataset either from a URL if we're using a public recipe, like from our public GitHub repository, which I clicked to earlier, or you can upload a data recipe from your local machine. And so when you upload these data recipes, they will run all the Python steps, maybe install some packages, pull the data from wherever it needs to be pulled, and then you will see that data set get added into Driverless AI. To modify a data set, when we're on the data sets page, we would click on a data set, we click Details, and then we'd be taken to the Details page. There's now a button that says Modify by Recipe, and we have three choices here. So the data recipe URL, again, is a link to the public repository or a link to anywhere on, the internet where your recipe might be. It doesn't have to be our GitHub repository. And then the uploaded data recipe would be to load from your local machine. So in this case, we're calling both of them data recipes, but one does load in data and one does edit data. There's a third option, which is part of the modifying data, and this is called live code. So what live code is going to do, you don't have to actually have a special H2O recipe format, which is a special Python class and a format that you can see if you're going to start writing your own recipes. Live code actually opens up a text or a text editor where you get the data frame as a data table object, and you can make any changes to it and then return that function, that table. So this is if you want to make really quick changes to your data, you see that one of these columns is incorrect and you don't want to include it, or you want to change your data type, or you want to change your target column from a regression to a classification, you can do that straight by writing Python code in the UI. And that is not going to change this data set. It's going to create a new data set. So you still have that lineage of understanding where data sets came from. All right, here's one that we mentioned earlier. It's not a recipe, so I didn't go over examples of it, but I just want to show you a short video of what's coming soon, because this has been a feature we've been asked for a lot, and it is a really neat customization option. So now in AutoViz, in a release coming soon, you have the ability to create any visualizations that you want to. So you still get all the benefits of AutoViz. It will tell you what's interesting or insightful for your data, but you can create specific charts that you want to. So if there's a chart that you need for a readout or a presentation, or you're sort of suspicious by looking at one of the other charts and want to know more, you can choose one of these 10 different options and create any of the charts on different columns. And that's something that could be really helpful for understanding your data. All right, back into recipes, our next option that we talked about is the data pipeline. So When we are running an experiment, there's an option called expert settings or expert experiment settings. This has several different choices. So you can do expert settings related to experiment, to a model, to different features. And what we're going to be looking at for the rest of the presentation is going to be expert settings related to recipes. So the option that we want specifically is include specific data recipe during experiment. If you add this in and you add in your Python data pipeline, then in the experiment page where it says what do these settings mean, you'll see a new section called data prep. In this case, I have a recipe called preview recipe. You do not have to have a data pipeline. Most experiments probably won't, but if you wanted to add in this pre-processing step that would run in production, you could, and this is how you would use it. Next, we're going to do our feature engineering. And again, there's going to be two types of feature engineering. So we have on the right here in the expert settings, we have the pre-processing transformers, and that's basically any feature engineering that you want to run first. And then we have the specific transformers, and that's any feature engineering you want to run after the pre-processing is gone. Currently today in Driverless AI, there is no pre-processing feature engineering, and it's quite possible that a lot of your experiments won't use this. You'll just have one layer of feature engineering. But if you want to add in the second layer, this is how you would do it. And then you'll see these on the what do these settings mean section under this feature engineering search space. And actually, our developers added a new functionality about 2 hours ago based on a request, just to tell you how fast it moves, where these will be split up. So it will show you both the pre-processing feature engineering and the post-processing feature engineering. So you can see those both separately and understand exactly how that's going to work if there is multiple steps. Next is going to be the specific algorithms we want to try. Now, this can be done in two places. In the recipes, we can turn on or off different algorithms we want to try. We can also click on the model section of these expert settings, and there we'll see a list of all the models where we can turn all the out-of-the-box models on or off. Now, since we're talking about custom recipes, I would be inclined to use the Include Specific Models tab instead, but there's two places where we can do this. And when you're looking at the game plan, this will be towards the bottom where I have a list of all the algorithms we're going to try. In this case, constant, decision tree, XGBoost, and so forth. All right, the last type of recipe that we're going to be talking about, the box is in the wrong place, sorry. The last recipe we're going to be talking about is the including specific scores, which is two options below where the yellow box is on the screen. And then this is a list of scoring metrics that you want to run. Then when you're looking at your experiment page, there's a section on the right here that says score, and that will tell you what score you're going to use. So if you added in a custom score, you would see the name of the custom score there. So you would know what your model is going to optimize for. So the last thing I want to talk about is how to do auto report customization. Because this is part of Make Your Own AI. Maybe part of making your own AI is how you're documenting it. So out of the box, auto report has a standard template that anyone that's used Driverless is probably familiar with. But there are expert settings for it that you can change this template. These are available either to change in the config file for Driverless if you want it to run for every experiment. You can also create custom auto reports from the Python client of Driverless AI. So these are the types of things that you can customize in your auto report today out of the box. You can add in any additional performance metrics that you might want to see in this report. Some examples of the ones we have available today are the population stability index, we have a Gini plot, we have some actuals versus predictive plots, and so forth. You can also point to a new data set and include diagnostics on this. So this could be useful in very specific use cases where you have a new test data set maybe 2 weeks later, and you want to know in a report fashion how it performed on that data. So you could create a new auto report, point to that new data, and get all the model diagnostics on those new data sets. All right, The other types of customizations we have today are going to be around model interpretability. So we do have a full section in the driverless UI on machine learning interpretability, but you may want to incorporate this in your auto report as well. And so you have the ability to add in variable importance, partial dependency plots, and ICE plots. And there's lots of features here. So if you're interested in customizing your auto report, this can be found in the config documentation for driverless AI. All right, I have a couple questions coming in, so I'm going to pause really quick and answer some of these because we're actually at a good stopping point. There's a question on if we had a connector to Teradata. We do have a way to connect to Teradata. This is through the JDBC connector. So we have JDBC connection to Teradata, and there is examples in the documentation on how you do Teradata specifically, but it is through the generic JDBC connector. You just need those drivers for Teradata. Yes, so there's a question. The question is, out of the box, it sounds like there's a lot of black box. Can we go under the hood? That's really one of the focuses of the auto doc, is it explains exactly what happened, and the expert settings allow you to completely control what you want to run. So not talking customizability in terms of adding in new features, but just customizability from expert settings. In the expert settings, you can go in and turn on or off different algorithms. You can turn on or off different feature engineering. You can get as detailed you want into the data science. So maybe you want to do a very specific depth for trees or learning rate for your algorithms. So you can be as controlled and hands-on in what runs in an experiment as you want to. And then all of that is documented in the auto report so that you know what happens. Another question, if NVIDIA, if we can run on different types of GPUs. Today it's just the NVIDIA GPUs. And then we're having a use case question on time series. And this is detailed, so I'm going to save this question for the end. It's a very specific use case, so we'll jump into that one later. All right. Because we're very close to the end. Okay, so we have gone through the different ways you can customize. I talked about recipes in driverless, many of which come out of the box, but the way to add in your own. Where we can find these recipes, which is in the GitHub repository, links throughout this presentation to get to that. So maybe you're ready to get started. We looked at how to consume these recipes, where to add them in the driverless UI. But if you would like a more detailed or hands-on overview of this, there's a great tutorial called Getting Started with Open Source Custom Recipes, and this will walk you through running an experiment using different types of custom recipes in the experiment to see how that impacts the models you're building. There's also a second tutorial, once you go through that one, of how you can start writing your own custom recipes. And so this is quite nice if you want to start writing your own transformers or algorithms or scores. And so I highly recommend, if this is interesting to you, go to the tutorial page and you can walk through these tutorials. The tutorials include the ability to use Aquarium, which is our test instances of driverless AI, or training instances of driverless AI. So you can go, spin up an instance, walk through the tutorials, and learn more, even if you don't have an instance yourself. All right, so we've talked a lot about driverless AI today. Just to really hit and drive home the major points, driverless AI allows you to build many models, many features, and test lots of use cases really, really fast. So you can build your algorithms quicker. We're able to augment existing teams. We're not replacing a data scientist. We're allowing a data scientist to get more work done faster and basically enhancing their productivity. And also, this is an enterprise-ready product. We can run wherever you need to, whether it's on-prem or in the cloud. It's a product that we're using for any type of supervised use case, so anything where you have data you want to learn from historically, and we're across industries. So I'm going to leave this up and go through the rest of the questions. If you have any questions, please put them in the chat and we will get to them. And if you don't, thank you for your time today. All right.
Okay.
There is a, oh, yeah.
Go ahead, Michelle. Go ahead, Michelle. Sorry.
Yeah, I'm just going to go through some of the questions. So there's a question, if data loading recipes can't be used in production, how do we get production code loading data as we did during training? So my first thought on this, when you're running data, when you're going to run a machine learning model in production, your data is coming from somewhere. That's usually going to be a business process. So that is not something that Driverless is doing. It's going to be something that your model is going to be streaming in, maybe through Kafka, or your data is going to come in from your business process as people are clicking on your website, or maybe it's in a SQL warehouse. But there does need to be some business process step that basically takes the data and gives it to the model. That's something that the model is not able to do itself. It needs to be ran somehow. Now, one of the things that could be helpful is thinking about how the scoring pipeline can be customized. The idea of the scoring pipeline is it can run anywhere. So the data loading isn't really in the pipeline, but you could have the pipeline run, say, in your SQL data warehouse. So if new data is streaming into your SQL warehouse, you could have the Mojo run as a UDF on that new data. And so that would be a way to have the model where your data is. So depending on exactly what your business setup is, that question might look a little different, but that's sort of how you would incorporate the scoring pipeline with the bringing in new data. There's another question on if we can use the zero-heavy regression for time series data, and you absolutely can. And so the way we do time series in Driverless AI, this could be its own webinar, so I'm going to do it really, really fast. But basically, time series in Driverless AI is focused on feature engineering. So we are creating time-related features, lagging on the target variable, lagging on other variables as appropriate, looking at exponential weighted moving averages, maybe using ARIMA as a feature. Once we create all those time-based features, we're then going to be running standard algorithms like LightGBM or XGBoost. And so we could absolutely run the imbalanced LightGBM or the imbalanced regression LightGBM. And so that can work with time series experiments. There's a question on if H2O's open source distributed random forest algorithm is available through custom recipes. It is. So this is in the GitHub repository. There's a section called models, and in models, all of the open source H2O algorithms are there. So if you want to use that algorithm, but with Driverless AI's automatic feature engineering, you absolutely can. There's another question about specific models, asking about TensorFlow and Keras. Great question. So yes, those models can be incorporated in Driverless as well. There are examples on the GitHub repository of PyTorch and TensorFlow models, so you can sort of see how they're written, and maybe the ones that are there already actually solve your use case. One thing to know related to that question, out of the box in Driverless AI, we do have TensorFlow models available. So there is a neural net that tends to do really well for high multi-class problems. So if you have like 100 classes of classification, that's when we would tend to use a TensorFlow model. We do also have TensorFlow for out of the box for NLP use cases. So we have word embeddings and character embeddings and bidirectional GRUs. Another thing is that, remember, coming soon, we will have, that was the wrong spot, BERT coming for NLP out of the box. So that's available as a custom recipe today, although you do need to talk to someone at H2O about that because it's not on the open source currently, but that will be another example of using basically neural net algorithms. All right, there's a question if work is distributed in Driverless AI in terms of the model tuning, feature engineering, and so forth. And that's a great question. So it is distributed on a single node. So Driverless AI is a single node platform today. Multi-node is coming, but that's its own conversation. So I'm going to talk about how it is today. If you have more cores, more GPUs, then you will see an improved performance because we are distributing across the machine. And so that's how distribution is happening today. Does H2O provide support for performing topic analysis? This is a good question. So in Driverless AI itself, we are focused on supervised machine learning use cases. So if you had labeled text data that you had already labeled some topics and you wanted to understand more about them or label new data, that's something Driverless helps with. But normally our topic analysis is going to be an unsupervised use case. So that's something that we're not doing in Driverless. We do have other platforms and other products coming, and one of these, Q, is looking into some topic modeling. And so that's a good question and something that's coming soon. All right. Another question. This one's longer, so give me one moment to read it. Okay, so this question is about how to set up a time series problem. So it says that we have one row per year, so it's annual data. And the first question is, can Driverless AI do annual time series data? You absolutely can, but the thing to keep in mind with machine learning is the more data you have, the better. So if you have annual data, but you only have 10 years of data, and you only had one group, that would mean you're trying to do machine learning on 10 rows. So, you know, if we have lots of years and lots of groups, then annual would probably be an okay or good use case for Driverless AI. But if we just have a small amount of data, in general, machine learning might not be the best choice for that type of use case. The follow-up question for that is, does your time series have to be a date? No, time series does not have to be in date format. You can have it sequential. So you can say this is the first, like, row 1, row 2, row 3, and know that those are dates for you, or you can translate them to actual date years. It's really up to the end user, but our time series recipes only need to know the order. Yeah. All right. Oh, a couple more questions are coming in. Okay. Great question. When a custom recipe is added, is it automatically used by the algorithm selection process? The first time that you add a recipe, I'm going to a slide. Here we go. So when I click when I click this button called towards the top, it says upload custom recipe. If I upload a recipe, Driverless is going to assume I want to use it. So for that first experiment where you upload it, you will see that new recipe you uploaded in your search, in your algorithm space or in your feature engineering search space. It's going to assume you just loaded this, you probably want to actually use it. But now that recipe is on your system and you can use it for any experiment. So the default setting is that the experiment will not use any custom recipes unless you turn them on. So basically, yes, the first time, but then after that, you'll want to go in and turn on any custom recipes that you would like to. All right, a couple more questions. The question is, will you add panel data models? I actually don't know the answer to that off the top of my head, but you can feel free to send us an email or join the community Slack and ask that question, and myself or someone will get back to you. All right. Oh, this is a good question. If it's possible to run TensorFlow algorithms in Driverless AI, can we pass images, for example? The short answer is yes, as long as they are labeled. So a lot of image use cases are not necessarily supervised learning, and like if you're trying to identify different sections in an image. But if you have any labeled images you want to learn from, those are use cases that we can do. We actually have, and that would go in the custom algorithms. This is available today as a custom algorithm. Your input data is going to look like a URL, a local file path to an image, and then there would be a recipe which is going to do image classification. The reason I didn't mention or talk about this today is because that is a whole separate new use case and recipe that's going to be available later this summer, and it will probably get its own webinar. Developers are very excited. We have a lot of people ask about this. So short answer is you can start to do this today, but something more robust is coming soon, and image classification will be out of the box available in Driverless later this summer. All right. Yes, so there's some follow-up questions on the images. For now, I'm going to hold off and say, especially because we're past time, and say image recipes are coming. It's something that our developing team has been working on for quite a while. It will be available later this summer, so stay tuned for that. All right, Patrick, any other questions?
I think that'll do it for now. Thank you so much, Michelle, for taking the time today and doing a great presentation. I'd like to thank everybody who joined us today. The presentation slides and the recording will be made available on our Bright Talk channel, and we hope you have a great rest of your day.
Thanks, everyone.